So here are the answers to the questions at the end of the previous chapter. Hopefully you've got all these right. So why don't you tick these off before we go on to heating and insulating buildings. U-values. Now U-values are a measure of how well a material acts as an insulator, and the lower the U-value, the better it acts as an insulator. So low numbers are good. Solar panels. Now these use radiation from the sun to heat water, and this hot water is then used either to heat the buildings, so it will flow around your radiators to heat the room, or to provide domestic hot water, so it goes through your pipes and comes out of your hot taps. So, cold water flows through the copper pipes in the roofs. It's heated by radiation from the sun, and then this hot water will flow out of the water tank. It will either come out of your hot taps as domestic hot water when you run a bath or when you run a sink full of hot water, or it can be used to flow around your heating system, so it heats the radiators which heat your rooms. Insulation is very important. The better insulated a building is, the lower the heat losses. Lofts and cavities in walls can be insulated using a material with a low U value. And this insulation reduces energy transfer by convection because it traps air in small pockets, so it stops the air moving around. Now, insulation can be very expensive, but the cost of insulation can be recouped over time because your energy bills will be reduced. And the time taken to recoup the cost of insulation is known as the payback time. Double glazed windows are good. Double glazed windows have dry air, which is a good insulator, or a vacuum between the two panes of glass. A vacuum reduces energy transfer by conduction and convection. If there's no air, then there's no medium for conduction and convection to take place. Specific heat capacity. Now, this is the amount of energy needed to raise the temperature of 1 kilogram of a substance by 1 degree centigrade, and it varies from material to material. Now, water has a very high specific heat capacity. It takes a great deal of energy to raise the temperature of a kilogram of water by 1 degree centigrade, a surprisingly large amount, much more than many other substances. And the unit of specific heat capacity is joules per kilogram per degree centigrade, or abbreviated like this, capital J / kg degree C. This is one of the equations that you'll find on the physics equation sheet, and you might in the exam be required to do a calculation on this. So this is the correct equation. E equals m times c times theta, that funny circle with a slash through it. So E is the energy transferred in joules, not kilojoules, joules. M is the mass of the substance in kilograms, not grams, kilograms. C is the specific heat capacity of the substance, and theta is the temperature change in degrees C. So here's an example. Here are 3 different substances with their specific heat capacity. So if you look at the 3 values for water, oxygen and lead, you can see that water has a specific heat capacity of 4,181 joules per kilogram per degree centigrade. Oxygen 918, lead 128. What does this actually mean? Means that water requires much more energy to achieve the same temperature rise as oxygen or lead? Let's look at these values again. If we had a kilogram of water and a kilogram of oxygen and we wanted to heat up both of these by 1 degree, water would require 4 times as much energy as oxygen. So, what sort of question might you be required to answer? A storage heater contains concrete bricks weighing 1 kilogram. When it's switched on for 5 hours, the bricks went from 20 degrees to 550 degrees. The specific heat capacity of concrete is 831 joules per kilogram per degree centigrade. How much energy was transferred to the bricks? So, first of all, look at your physics equation sheet, which comes in with your exam paper. Find the correct equation, E equals m times c times theta. The first thing you do is substitute into that equation all the values you've been given in the question. Often this will be a 2-mark question. If you substitute the correct values into the correct equation, that'll be the first of the 2 marks. So, m, that's the mass of substance. That's a kilogram, it tells you in the question. The temperature change, well, it went from 20 degrees to 550, so the temperature change is 530. That comes from the question. And the specific heat capacity, that's 831. That comes in the question. So all you have to do then is carry out that calculation. 1 times 530 times 831. The answer is 440,430 joules, or 440,430 joules, or 440.430 kilojoules. Okay, so quickly test yourself. Hopefully you've printed out all these notes so you can answer it now and find the answers at the beginning of the next chapter.